Yeah, hello and welcome to today's session. I'm excited to have you here. And we'll continue from our previous session where we imported our data and we now have our data in this data and it's ready for analysis. But before we start the main analysis, usually we may want to prepare the data, clean it, make sure it's in the state where we can use it for proper analysis. That is to say, we may want to check for duplicates. We may want to look out for outliers, especially with continuous variables. We may want to make sure that all our variables are properly labeled. The values of the variables are labeled also. And we may want to check a few things. Recode variables that we may want to be in binary form. That's the zeros and ones for future analysis. So we have quite some grounds to cover here. But for me, for best practice, I usually like working within a do file. That is to say, I have a file where I keep track of all the commands I use. And with this particular file, you can execute the command directly from that, especially when it's linked to your stata command window. And once you execute that, you can see your results, and you can save the do file. You can reproduce the same results and commands in future. So it's a good way to do analysis. So I would advise you and suggest to you that if you want to stay in the business of data analysis, you should consider. So if you want to activate your do file, you go to Window, go to do file editor, click on new do file editor. It opens a do file. So the do file is basically a text file, just opens it, but specifically for data, where you can write all your codes. That's the commands, and then you can comments. So comments are basically information you put in you put in your do file just for explanation or to give some background or something, but it's not executable, as in you can't run this as a command. So for instance, we know the tab command is used to generate tables, right? Variance and frequencies. But for instance, when I start the tab command with an asterisk, then the tab becomes a comment and not the command again. But if I don't, and I just write the tab as a command, and then I bring my variable maybe age, then in this case it's just a command executing the variable age. Okay, that's about it for commands. So once I bring the asterisk, then it's a command. Okay, so today we'll be covering a number of grounds. We'll look at we've already looked at how to import data, and we're saying we're going to look at how to prepare or clean the data set once it's in our data. Okay, so how do we clean? What should we look out for? When cleaning data, best practices are that for me, I usually would first start with ensuring that the numbers are right. And how do you ensure that? We want to look at summarize the data to be sure that the sample sizes you were given what they are. Okay, so a simple summary command would give you that. But you also want to check out for duplicates. Okay, so duplicates, we'll go through how to check duplicates. You want to look out for outliers. Okay, we want to look out for variables that haven't been labeled, the values that haven't been labeled, so that we can do all those. And we want to recode binary variables. Okay, for further analysis. So we'll look at these. We have some grounds to cover. Okay, so stay with me as let me just organize my desktop. Okay, great. So these are the things we'll be looking at, and this is our data tool that we'll be using for the cleaning and data processing. Again, if you missed out, this is the results window, right? This is our command window. Okay, so let's look at duplicates. We've been able to import our data. Now we have data of about how many observations? 186 observations. Okay, on women. So this data is actually data on 166 women. We ask them questions to ascertain their knowledge and their practices relating to nutrition among pregnant women. Okay, so basically that's what the data is about, and so we'll be using this data set for our learning process regarding data cleaning and data wrangling. Okay. Okay. So I mentioned that to have a cursory look at the data, we want to browse the data. So once you browse the data, br command, the browse info, it gives you an overview of the data, and you can see how the data looks like. Okay, by looking through the data this way, you wouldn't be able to tell whether a data or an observation has been duplicated or not. Okay, but there's a way to do that. We can use a command to quickly check. Okay, so when we come here, we use the duplicates command. Okay, so the duplicates command. So we type duplicates reports. So duplicates, we need a report of the duplicates, and then for me, as I said, I like to work within my do file, so I'm keeping record of that. So duplicates report, and then it gives us a report of the duplicates. So it says duplicates in terms of all variables. So it picks all your observations, picks them variable by variable. So it means all the variables when it within our data sets, there are about 3 observations that for all the variables they are the same. And which ones are these? So how do we do this? We can easily create a variable that would isolate these 3 observations so that we can browse only them to see those variables or those observations that are duplicated. So we can do this by running duplicates tag. Then we generate a variable called dup. Okay. Again, want to save this for future reference. Then we run. So it has created a variable. When you browse to the last part of the variables, we see that there's now a new variable here that has been created. When we tabulate the variable, we see that it's similar to what we had. So 0 are the unique variables, and then 2, it assigns 2 for 2 variables that have been duplicated. Just like when we run the duplicate report here, where it says that variables that had unique copies, 1 copies each, were 183, and those that had 3 copies were 3. Okay, so with this we can easily browse and use a constraint if use a condition, if our the value for duplicate is 2. So if the value for duplicate is 2, and then it browses these 3 observations. So we see that the unique key here is the same for all of them. The form version is the same, and the date of submission is basically the same for the 3. The start time the same, end time the same, and enumerator is the same, age is the same. So basically for all the variables, everything has been duplicated, is the same. So we may want to deal with that. So once they're duplicates, we don't want the same data repeating, else it would bias, will lead to result in bias. So we don't want to let that affect our data and our analysis. So we may want to drop the duplicated or the duplicates. There are different ways of doing that. Okay, so we can just use the drop command, and then we can just use the drop command if, then we go and Okay, can use a drop command. So for instance, can let's browse again. Okay, we see that for this it's in row 4, this is in row 185, this is in row 186. Okay, so we can just say drop in 185, and then it will then browse this and come back in, drop in 185. It has deleted the 185 observation now, and because it has dropped that, the row goes and it brings back, it shifts the observation back to 185, so we can drop back 185 again. So for instance, when we browse again, we see that it's still 4 and then 185, so we may want to drop 185 again. Okay, so now when we go and we check our duplicate reports, the unique variables observations are 184. So that's how to deal with the duplicates. Okay, you just identify them, use the duplicate reports, identify the duplicates, then you may want to drop them. Okay, so the next thing to do we'll be looking at is outliers. Okay, so what are outliers? Outliers are basically extreme unusual figures. So for instance, we're looking at ages of women who are 18 to 60 years, pregnant women, to measure their knowledge on nutrition. And in our data, when we are browsing, we probably realize that for the age variable, the numerators went and entered age of 1000 and 2000, or out very extreme. So let's look at what the data says. So we browse the data, we go to age. Yeah, so we are looking at age, and this is the age category. So we come here, we see that someone entered an age of 9,999, and then you get here, another person entered the year that the person was born in 1995. Okay, and then here someone entered 100. So 100 might be realistic, but it may be an outlier, because when you look at all the data points, they may not what's the name? They may not be they may all not be around close to 100. Okay, so that way you are able to tell. But there are other ways you can easily check for outliers. Okay, so you can use the box and whisker command. So graph box age. So we browse our age variable. Then to generate a box plot, and then show us those variables that are outliers. And so it has done that. It has given us the outliers. So here it's not really that clear. Okay, it gives us a picture of how the outliers are. Else, what can also happen is we can just tab the age variable. We can just tabulate the age variable, and then we see those variables that are outliers. Okay, so you see that the minimum age is 18 up to 40, then from 40 all the way it shoots up to 100. Someone who is about a woman who is about 800 years old, and then we have 1995, 999, and there are different ways of dealing with outliers. We will look at that in subsequent videos. Okay, but then just to add that with survey data, mostly when things like this happen, you may want to double check. Okay, so you may track the observation that has this age, and just make a follow-up call to be sure that the person is actually 100 years. And you may want to also cross-check the actual age of this person who has entered 195. And sometimes with data collection and data programming. We in programming the software for collecting the data, we usually assign 999 or 999 as figures for unknown values. So maybe an enumerator entered it to show that the age was unknown, and in this case we may want to recode this as a missing value. So to recode this as a missing value, I just use the recode command, and then I say that the enumerator entered 999 because it was missing. Okay, and so I would have dealt with the outlier. So that's for outlier. Okay. Now when we tap that again, we realize that that has the 999 is no longer seen here. We still have the 1995 though. So 1995, the person is roughly about 29 years, but because we don't know the month and date, so assuming we had called and the person actually confirmed that they were born in January 1st, 1995, so 29, 30 years now. So it's safe to do what? To change this 1995 to 30 years. So just recode 1995 to 30. Okay. And then we can keep a record of that here. Okay. So you see that when we tap again, that is also gone. Now again, we are still left with an outlier because when we check all these, they are within the ranges of all the from the distance between or the variation between 40 and 100 is so huge. That is to say, if we had summarized the mean age, you'd realize that this variability would have, or the variance of this would have been so far from the mean, and so we may want to just deal with that. That is to say, we may want to recode it as missing or an average of these. There are different ways of handling missing values. Outliers. Okay, but assuming we do that, right? So let's say for our case, we decide that we want to recode that 100 to missing. Okay, so missing, so that once it doesn't affect, because mind you, averages and means are affected by outliers. Okay, that is the one disadvantage of means and averages. So once we do this, now when we run the mean of the variable age, we should get the actual mean of the rough estimate of the sample mean of the age. Okay, so this is about dealing with outliers. Now we may want to look at labels. Okay, so let's go to labels. So for labels, we have value labels and variable labels. Okay, so what do I mean by value labels and variable labels? So you realize that if you are in you're already in the research space or primary data collection space, you'd have realized that once you go to collect data, you go with questionnaires. So you probably asking the person, how old are you? So age of respondent. So this variable, someone may not know what this variable actually stands for unless we label we properly label this, so that it would have been age of respondent. Okay, and this would have been residence of respondent, and this would have been marital status of respondent. So how do we label this? So we can just use label var, and then this age, we use the command label var label variable. So you can write them in for label variable by just in short var label var as age of respondent. Okay, then we run. Now we see that the label here is just age of respondent. Okay, so age of respondent. Then we can label var this as the residence of respondent. Okay, copy that also. Create space here. Okay. Label. Okay. So once we run it, labels it properly as a resident. Now the last one we'll be labeling is marital status. So lava this label marital status. Okay. And then we see marital status. So that's about labeling the variables. But there's another leg to it. Now with the variables, so for instance, when you pick a variable marital status, the person could be single, married, divorced, the person could be widowed, cohabiting. So well, let's tap this. Great. So marital status, so rather we have 1, 2, 3, 4, which means the labels for these values are not given. One could be married, one could be single, we don't really know what exactly. So and we see this because when we were collecting the data, right, in the programming, we pre-coded these variables and gave them values as 1, 2, 3, where 1 actually is single or married, 2 is cohabiting or something. So we'll go to the printable version. We have where in the questionnaire actually to see how originally they were coded. So 1 is married, 2 is single, 3 is divorced, 4 is widowed. Okay, so we can actually label what we have in our theta to follow the same distance. Okay, so in doing this, we just go to label define. We use the command label define, and then we say label define married. Then we give, what are we defining? We are defining the labels of these values, the values of this variable. Okay, marital status. So we can give the labels we are defining married. Then we say 1 here should be what? 1 here is married. Okay. Okay, just so that we are not confused. Label define. So maybe we can say marital. Okay. Then 1 here is married, 2 is single. Then 3 is divorced. 4 is widowed. So great. So once we have this, copy this and bring it here. Then run. But then we still haven't, when we tap marital status, you see that the labels haven't been attached to the values of the marital status. That's because we still haven't attached that yet. We've only defined the labels for it. So now we want to attach the values, the labels to these values. So we simply say label values of the variable marital, A3 marital, with what? The labels we are defined here. Okay, and so now we've actually labeled those values. Let me copy my command again and keep it here. Okay. Now once we tap this, it comes with what? The values, the labels of the values. Okay, so that's how to label. So far we've covered dealing with identifying duplicates, dealing with them, outliers, dealing with outliers, labeling, and then our next thing would be to look at binary variables. So binary variables are just simply the variables that take on zeros and one. And mostly they come in handy when you want to do regression analysis. So for instance, we are saying we are measuring, we are looking at those who, so let me just pick one of the questions. Uh, yeah, that asked whether does good nutrition involve eating a balanced diet? That's this question, C1. Okay, so C1 says that asks whether good nutrition involves eating balanced diet, and one was yes, zero is no. So one yes, zero no. So this is basically a binary variable. Okay, okay. So that's about binary variables. Okay. Thank you very much for joining in for today's session, and thank you. I hope you've learned a thing or two. Do all to subscribe for more learning experiences. And yeah, if you have any comments, anything you want to contribute, anything you want to share, anything you want us to learn more or explore more about, you can do all to comment or reach out to me. I'd be grateful to respond to your comments and your contributions and concerns. Thank you.